All right, so let's pull up our work order. The tank would not fill. The operator reported no abnormal condition. So got it where you can see the larger parts of these things. Tell me, do you see something missing? What's missing here? And I'll give you a hint. There's something indicating, at least in part, that we're not where we can be at a port that we're ready to start this piece of equipment. And it has to do with this right here. So what is missing? Okay, so if you answered that the ready light was not on, you're in the right ball game. So question 2 would be, where am I going to go to troubleshoot why this ready lamp is not coming on? And if you answered, I'm going to hook up my laptop and look at my program. You're absolutely right. So I'm going to find the rung that has the ready lamp in it. And there's the ready light and the ready relay. And I want you to tell me what condition is keeping my ready relay from starting. All right, if you answered that the low float switch is not open, it's actually closed, then you're right. We're seeing a state where the low float should not be on, yet it is. So that's preventing this from starting. So here's the next question. How would we test that low float switch? We know it's in here. We can come up here and we know how these work. We know pin 1 has 24 volts, pin 3, pin 5, pin 7, and we know that 24 volts should go to each of those pins, the pair of pins when it closes. So pin 1, 3, 5, and 7 should have 24 volts on at all time. So if the low switch is closed, we'd have 24 volts on pin 2. And what about that we do? But we know none of these others are closed. So yes, there's none there, and none there. So some reason the low float switch is closing. Now, if we had fluid in there, we should be able to see it in our sight glass. We can see our sight glass goes below our tank, but yet we see no fluid. So what do we need to check next? Well, if you answered we physically need to check our low float switch, that is the right answer. So we're going to lock out our piece of equipment as we would. And we're going to come up here to our float switches. And oh yeah, it's already open, that's why. And we're going to try to change out the float switch. And anytime we can inspect, we're going to inspect. And it says one of the float contacts is shorted. So that's why the contact was shorted. Didn't matter what state it was in, we're always going to get 24 volts. And we're going to replace it. And we're going to check it. And we're just going to see if that took care of our problem. We're going to return our meter leads. And we're going to start the machine. Sounds like we're milking a cow. And we're going to do it one more time. And read the program overtrain. That's good. So we're going to see if we passed. Yes, right. Just a few more seconds. We're passed here. And we did. So, simple observation. We came in, we noticed our piece of equipment did not have a radio lamp. The easiest way to diagnose the radio lamp was to look into the PLC, see why the radio lamp was not in a start condition. We saw that it thought the low float switch was still active. We checked it, and sure enough, it did appear the low float switch was closing, even though there was no fluid. We took and cut off our power, diagnosed and checked our low float switch, found it was shorted, replaced it, and we are back in business.